Good morning, everybody. My name's Jackie Boyle from Sydney, Australia, and it is always my pleasure each week to be able to introduce the esteemed Dr. Joseph Ahrens, dual-nominated Nobel Prize scientist, to be able to share with us invaluable knowledge that he has in a library of life. And today's topic, we are going to be talking about when we start looking about timing of when it's beneficial for us to consume food and why. And, you know, one thing over the years, like we had a fitness center for over 25 years, and it was always quite fascinating to look at people that were wanting to manage their weight a little bit more efficiently, that we would always say to them, try and come in and exercise if you can at 6 a.m. in the morning, and try not to consume any food if you can prior to exercise. And there's a very big reason for that when we start looking at timing as to why it's so beneficial. So this is why it's going to be very exciting today, because it all falls into alignment with what we're doing with the products that we have, but also just in general lifestyle choices in our food and our exercise, why I think you're all going to get a lot out of this call. So how are you, Dr. Ahrens?
I'm just great. I'm very glad to be here. I thank you for everyone joining us this evening or this morning, depending on where you are.
Yeah, so, you know, we're going to talk about today, like why it's so important about timing of when we eat that's going to benefit our body to be able to be, to be able to burn body fat more efficiently, I guess, really. We're not making any claims here either, anybody, but we are just trying to provide information. So I'm excited for you to be able to share your thoughts in this area, Dr. Ahrens.
Well, it's very important, and some people do pay attention to it. Other people don't know what it means, and maybe we can clear up some of those issues.
Well, I will turn it over to you, because I know that, as I was saying, like personally for myself, I've seen a lot of benefits for people that have actually chosen to get up and exercise first thing in the morning before they consume something to eat, because they're doing a certain thing when they choose to do that, aren't they?
Yes, they are. Yes. So with any further ado, we can get right into it. Is that okay?
That's wonderful. I'll hand it over to you.
Well, you know, you got to understand a little bit about the biology of the body. The life goes on 24 hours a day. And many mammals like ourselves are diurnal, which means we have a waking period and a sleeping period. And our bodies are adjusted, have evolved to have activity when it's daytime and have less activity when it's nighttime. And you got to look back to the early days, you know, like prehistory. Where were we before we had modern agriculture and modern science and modern lifestyles? You know, this currently in most of the part of the world is 8-8-8. You know, it's 8 you're working, 8 you're kind of relaxing, 8 you're sleeping. That's actually a very new phenomenon, even at the turn of the century before last. So, you know, I'm already 70 years old. I said last century. No, wait a second. That was 2 centuries ago. Okay, the 1900s or so. People were basically doing 12 on and 12 off, and now we've moved into 8-8-8. And you know, the French, they've moved into 2 hours of work and 12 hours of play and rest, sleep. Okay, just a little joke there, but most of the world is on an 8-8-8 cycle. It's actually not very biologically active. You know, you got up in the morning. We talked about getting up and being light aware, and the sunlight charging you up and waking you up, and your sleep chemicals going down. And during the day, your active chemicals going up. And you went out and you looked for food. And you went throughout the day looking to get whatever you could. There were not gardens that you could go out to and just get what you wanted at any time. You were hunter-gatherers. I mean, all of us, we may not all agree on exactly what we did, but we all, scientists, agree that we were hunter-gatherers. And you got up in the morning after the light came up, had a little bit of eat to energy to maintain you. You went out into the woods. You had mostly a circuitous route where you knew where the game was, you knew where you could find the berries, you knew where you could dig for roots, you knew where you could dig for bugs. Yes, we ate a lot of bugs and got what animals that you could. And then every now and then you came across some wild grains. You grabbed those, rubbed them together, and ate them. We didn't actually have ovens and things at this time. And your eating cycle was basically in response to the energy you needed. And whenever you got a big game animal, you'd haul it back to your camp, your housing community, and you'd feast on a lot of fat and protein. I'm sorry if you're vegan or vegetarian or whatever, that's what we did. And you load up on a lot of fat for energy. Well, we've gotten past that a little bit. I'm thankful for that. That we've got into a routine, but really the underlying biology is still there today. And we need to try to coordinate and work with that for optimum results. So let's look at our body as we got up in the morning. What is the energy in your body? Well, you've been fasting. I mean, that's why we call it in the English language breakfast. It means break your fast. You have not eaten for about 12 hours. It was nighttime. You didn't go to the refrigerator at midnight and get a snack. You know, you were sleeping. And we talked about the sleep cycle previously. Go back and review some of those talks. You got up in the morning, you took a little bit, what was left over, you're totally depleted of readily available energy. Now, the energy in your body is held in 4 different ways naturally, without any strange action on your part. First, you have glucose in your blood. Glucose, that is pure sugar, you know, the stuff you get in the hospital when you're in an emergency. It's also where, you know, the sugar that's in honey, and even table sugar is half glucose and half fruit sugar, glucose and fructose. And your sugar in fruits is fructose. The sugar in milk is maltose. So the free, simple sugar, that is flowing around in your body all the time. And when somebody that is normal and does not have diabetes, they wake up in the morning, their sugar level in their blood is around 70 to 100. That no matter what the scale you're using, they translate the same way, 70 to 100, either microliters per liter, 70 to 100. Sometimes 110, but usually, you know, 90. That 90 is a real good number, and it's hard to remember, so I say 100. And then as you eat things, whatever's available, a fruit or any type, even something you don't think has sugar in it, everything has sugar in it one way or another, even meat. Your blood sugar raises up over the next couple of hours, and then it starts falling off again. And that is the normal pattern. You eat, your sugar rises up, should rise up slowly, and then falls off. And then you eat another meal, maybe, you know, 6 hours, 4 hours, whatever habit is, it rises up and falls down. And that is glucose metabolism, and that is a rapid source of energy. It's what you get when you eat candy, pancakes, bread, get you going, glucose in the blood. That is the first source of energy for your body. Number 2, what happens when you run out of that? Then you have what we call mammal starch. It's galactose. It is sugar in a more tightly bound form that's actually in your muscles and in your liver. And there's a little bit everywhere else. So some in your brain and all these tissues. If you happen to run out of glucose, then you go to galactose. And it's a more resistant type of energy, and it's more bound because your body wants to run out of the quickly replenished glucose before it gets into your animal starch. It's a way for your body to store energy in the medium term. After that, you can get energy from fat. Fat is actually fatty acids. Fatty acids. You know, when you eat a bunch of fat or oil or lard or whatever you're eating, it doesn't just bunch of clumps of fat floating around in your blood. People think, okay, I eat a lot of fat, and it's a bunch of clumps of fat, and it clogs my arteries. No, that's not how it works. It breaks down into actually half little pieces of sugar. Fatty acids, they are half sugars, usually three carbon units, and they have an acid attached to them. That's why we call them fatty acids. And they store a lot of energy. They store 2 to 3 times more energy than sugar itself. But that's what's floating around in our bloodstream. But the fat itself, condensed fat, lives in our fatty tissue. And it's not just in our bellies, it's all over our bodies. It's in our brain, it's in our muscles. And so that's the third source. Okay, what is it? Let's repeat. Glucose, blood sugar. And then we have the starch, mammal starch that's around your muscle tissue. And then we have fats. Now we do have other sources of energy. 2 other main sources. One of them is we don't have it in our storage, but if your body runs out of sugar, it will make its own sugar from like lactic acid. And it's the scientific term is the Krebs cycle, triglyceride cycle, where if your body sees, hey, I don't have enough sugar, it will make its own sugar. And so sometimes even before your body can shift into using your muscle starch, it will make its own sugar. That's partly the reason that you get aches and pains in your body. It used to be thought it was all the reason, but no. Part of the reason is you start making sugar from acids, and you burn sugars without oxygen because you've run out of oxygen in your blood because you're exercising so much. You switch into anaerobic oxidation. You don't have to memorize this. There's not going to be any tests at the end of this talk. And you make your own sugar, but the acid will build up in your bodies and is actually quite painful. You get lactic acid and it gets sore muscles. And then you switch into the muscles using the muscle starch. And then when you run out of that, you start chewing on your fat reserves. So that's fairly simple. Now I've told you several times, we're all animals, we're all different. It's all biology. Everybody will have a little bit different cycle, but that's it for most people. Glucose, muscle starch, body starch, I like to call it mammal starch. And then you got the fat itself, and in between then, based on your individual, so can you see I'm doing that between number 2 and number 3? You have your body can make its own sugar, gluconeogenesis. I would like to throw in here something we're going to talk about in a couple of weeks from now, and that's the use of ketones, which is tightly related to the fatty acids. You can burn ketones. When you run out of all these other things, you can burn ketones, which simultaneously promotes the burning of fat. And that's what we call ketosis and the low carb diet. So that does figure in there, but that's a severe case actually, when you force your body into what we call ketosis. And we're going to talk about that when we start tackling diets. But you got to remember those 3 things there. So, okay, what do you want to do? You want to manage your weight. When should you eat? When should you not eat? The worst time to eat, let's start with that one, is right before bed. You load yourself up on whatever you eat, proteins or carbs or fats or whatever, and you go to sleep. What's your body going to do with all that stuff? It sees no demand. It sees no demand. Well, your body's smarter than you are. You say, well, we got a lot of extra food in our stomach, and there's sugars in there and carbohydrates, and the insulin's peaking. Let's put all that in the fat tissue. And that's the best way you can gain weight, is to eat a lot and then go to sleep, or eat a lot and don't be very active. That's the greatest way to gain weight. So let's say that's the best way to lose it, is don't eat a big meal before you go to sleep. Okay, I'm like most of you on this call. We're in a so-called Western culture. We eat at 6, 7, and 8 p.m., and that's probably one of the worst things we could do. We should eat a big meal in the middle of the day or a big meal in the beginning of the day, but we don't do it. You know, we've been forced through our social system to work all day and then get in the evening with friends and families, and then that's when we have a big meal. Now, I was very interested in the Spanish because they eat 10 o'clock at night. It's amazing, you know, their whole day is upside down. They start out in the middle and they work, and then they stop, and then they go back to work, and then they stop, and then they have this big meal. You can find yourself eating a big meal at 10 p.m. or 12 p.m. and then try to go to sleep. That's a very interesting society. I love it. So, but you know, also the types of things they eat are a little different too. So do not eat as you're getting ready to go to bed. It is really better if you're going to eat the most, eat in the middle of the day. And I will admit right away, I don't do that. So I'm not just preaching to the choir. The preacher doesn't even do it. I eat at 8. I love to eat at 8 o'clock, and it's really not good for me. But I also don't go to bed till midnight or 1 a.m. So that's a little better. But you're killing yourself literally if you eat at 6 and go to bed at 9 o'clock. Don't do that. All right, that's the first rule. You need to eat and then use that energy as much as possible to begin with. So everyone then goes to sleep and they fast. You know, people, when you say, well, do you fast? People think, oh, I went 1 or 2 or 3 days without food. No, fasting means how long did you go without eating? And it could be 2 hours, it could be 8 hours, 12 hours. But outside of not eating for 1, 2, or 3 days, when we stop eating for less than a full day, we call that intermittent fasting. That means that you will take a period of time, including your sleep time, and not eat. Now, if you just stop eating from 8 p.m. till 6 a.m., they really don't consider that much of a fast. That's just normal. But if you go longer than that, then that's called intermittent fasting. So when you eat at a certain period and then you don't eat. Let me give you a really good example. Let's say you got up and you exercised and you went about your day and you ate lunch at 12 o'clock. And then you went throughout your day and you had dinner at 6. And then you didn't eat anymore until the following day at noon. That is what we're talking about, intermittent fasting. And that's actually gets back to what we were normally what we used to do. So you got up when you were hunter-gatherer. There was not much to eat there. You know, the campfires burn out and there's not a lot of food. You might grab a mango and eat it, and then take off into the bush looking for food. Come back, it gets hot in 12 or 2 p.m. and you come back, or you camp out in the shade. You get game, you drag it back to the home site and then slaughter it and eat, and then go to bed, you know, when it got dark, and then the same thing. So they were actually doing an intermittent fasting compared to modern diets. That would not have been called any type of fasting back then, but it would be today. Let's couple that then with exercise, because we don't get up in the morning and take off into the bush looking for game. That was their exercise, you know. We didn't have people in those days doing programmed exercise. The reason we exercise now and we tell people you need to exercise is because that was their life. They exercised and they ate. They every now and then had to sprint, run away from animals. They climbed trees. Every now and then they lifted up a big something or another, rock or log, go back, eat, sleep when the sun went down. That's what we're trying to get back to, because that is what we are still built to. We have not changed from them. Our DNA does not appear to have changed since then. There have been only slight changes in the human genome in the last several thousand years. The most prominent one is our tolerance for milk. We were not actually made to drink cow's milk. And most of the world is still today lactose, the sugar in milk, lactose intolerant. And I will put a little flag in here for, you know, that's a type of inherent in the society, racism or whatever you want to call it, because there were, back in the 1800s, all science was around London and Paris, and they thought that it was an aberration when they found societies that were lactose intolerant, and they said, oh, they're the weirdos. Come to find out, it was London and Paris that the weirdos. Most of the world cannot take lactose. It was just them, because they had to depend on the milk of animals. And by the way, that's where all of the herd animals come from, is around London and the Channel Islands, Guernsey. These are Holstein. These are all cows that were developed there. That was the animals that were available. If they were going to survive, they had to use their products, including their milk products and the cheese they made from them. And they evolved to be tolerant of that. Most of the world is lactose intolerant. So you've got to look at, what were we really as a human genome? Where were we a few thousand years ago? Certainly 10,000 years ago. Where were we? We were lactose intolerant. We got up, we ate meat, and we didn't eat for a long time. We'd get up in the morning, we'd take off exercising. You didn't, do a slow buggy stroll and go out and look. No, you got into a jog and you exercised for long distances. That is we have to piece this all together. This is how humans hunt. Long-term jogging, cardio for extended hours to find the game. And humans are able to persist like that when these other animals have fast twitch muscles. We have mostly slow twitch muscles. They just go and burst like cheetahs and jaguars. We could hunt them down just by being persistent at a low jog cardio. Does this sound familiar to what medical professionals, health professionals are recommending? Yes, cardio almost every day. And every now and then a burst of high intensity cross training. So they would exercise, they finally get the game, and they would come back, and then they would eat. This is what I do. This is what I recommend to people. Everyone is different. You have to find out your own pattern. Just like I've told you, I'm a night owl. I don't want to go to sleep. My body's cycle is about 1 a.m. and I get up at 7 or 8. That's basically a night cycle. I'm not an early riser. I'd like to be, I'm not. So I can't tell you, get up at 5 or 6, crack of dawn, do what your body wants. But I get up early, 6 or 7 o'clock. And after a little quiet time and waking up, and I do have a cup of coffee, then that's when I do my exercise. For me, it's a jog in front of my property here on the beach, and a couple of miles. And every other day, I do that almost every day. Every other day, I do more high intensity cardio or resistance training. And that's my pattern. I come back and then I have breakfast. Then I really do break my fast. That's somewhere around 10 to 12 o'clock in the morning. So that's my intermittent fasting. I do not eat past 8 o'clock p.m. and I don't eat again until somewhere around noon. That's a pretty long fast for most people, but that's an intermittent fast. That's really quite, I recommend it for me, not for you. Do what you want. Okay, there's one other thing I do though. Because of those, I just told you, glucose, glycogen, fatty acids, so a little keto thrown in there. I don't want to exercise and then my body start using my own protein as a fuel. And that's the fourth one. Your body can run on protein. At the same time, it switches over to keto. It also will start consuming your own protein. Protein is energy. We eat it for energy. Protein has carbs in it. That means it will burn. That means it will make energy. Anything that burns has carbs, and any carbs will make energy. So in order to avoid burning up protein while I'm exercising, I take just a little bit of what's called BCAA. That's branched chain amino acids. I mean, I'm talking about a teaspoon, just enough in some water, and not enough to tell my body I've come out of a fast. I don't trigger it into looking for, steak and eggs in the morning. Just enough so I'm sure that I've got enough of those in my body, because I want to be sure I have enough. I want some glucose in there. You have to have some glucose in order to sustain your energy and to maintain muscle mass. You have to have some carbs. I wake up in the morning, so since I'm a scientist and I check myself all the time, about 90 is my blood sugar level. That's good. If it was 70 or 60, I'd take a little supplement of some sugar or something. Stay around 90 or 100, somewhere in there. And I exercise pretty vigorously for about an hour. And then I come back and I might have a glass of milk even. And then I eat about 11 or 12. And then I don't eat again until 7 or 8 p.m. at night. For me, that works perfectly. Why? Because, it forces my body, in this case, to burn fat and increase muscle mass. You don't want to be burning your own protein. That's really complicated. And we're going to talk about that in a couple of weeks. So that is an example of the two major things about, well, it's not just about eating when you should eat. I want to let you know two things on this talk. First of all, do not eat your big meal before you sleep. That is the worst thing you can do. That will not only it does make you sleepy. Why? Because all your blood leaves your brain and goes to your stomach. That's one of the reasons you get foggy after even eating a big meal at noon. But all of that's going to go right to fat, because you have no use for it. You're not spending a lot of energy. You need to avoid that. Number two, if you're trying to lose weight, manage weight, then you should work out fasted. Eat after you have exercised. Eat after you have exercised, because then your body will get quicker to using those fat stores. Use up the glucose, then it will go right into your muscle starch and then into using fat. Now you must, if you're really going to do a good job, you've got to exercise for like 2 hours to really dig in to the fat stores. But even if you use up your muscle starch, it will be replaced by fat coming out as fatty acids into your bloodstream, and then turned into sugar, and then go into the galactose. So Jackie, has that been clear enough to you? What else should I clear up?
Well, I'm just looking at it and thinking that myth or fact, fact being, from what I've gathered from this, Dr. Ahrens, is that, it is good to actually do the intermittent fasting for some people. It's a personal choice. But definitely if you get up in the morning, and fact being is that if you do not eat and you choose to exercise first thing in the morning, you're going to be burning fat stores as your energy. So you're going to benefit from that to be able to assist your body to be able to manage your weight more efficiently. Is that correct?
Yes, if you are really primarily want to get rid of fat, you absolutely need to exercise fasted. Take just a little bit of sugar and protein to get you through that energy, so you don't end up burning your own protein, your own muscles, just enough. I mean, not even like as much as an egg, just like a teaspoon, a couple of mils of that. And then you should never eat late in the evening. I don't care for anybody across the board. Do not have a late meal. Those are the two things that you will get the greatest success at. And as I said earlier, we will get into some of the more mechanics and chemistry of that process in a couple of weeks when we start talking about different diets.
And then, of course, like if you eat late of a night too, Dr. Ahrens, you've got the possibility of it's going to make your sugar levels go up too, isn't it? Which is going to add to the potential of gaining weight as well.
Yeah, because you're not using it. So it's not driven to suck that sugar out of your bloodstream as much. Well, you're confusing your body. You're supplying it with fuel and then you're doing nothing. We were actually built in order to use food, eat food, and use food. And then every now and then when you came across a big store of food, a lot of food, boom, it goes immediately into fat. And that's what we're doing all the time in the modern diet, is we're telling our body, wow, lots of food, eat all you want, turn it into fat. Without our brain, it's what it's doing automatically. So it'd be a lot better to eat a lot more smaller meals throughout the day. Yes. And when you have that big meal, it should not be late at night. And you should exercise beforehand. Now, some people are going to come back to me and say, oh, I'm totally opposite. I love to exercise at night. It calms me down. And I will just say, great for you. You're only 2% of the population, because that does not work for most people.
And then, Dr. Ahrens, just for those that are avid, they're avid exercise lovers and they're exercising on a regular basis, there is an exception to what you're talking about, because if they're going to be exercising, like if we're looking at an elite athlete or somebody that is in that industry, they're going to be grazing throughout the day because they're going to have to replenish what they're burning. Otherwise, they're going to end up burning into their muscle mass, right? Because they don't have a lot of fat stores generally when you're looking at those type of people. Is that myth or fact?
Yes, no, that's true. A person who is exercises, who's an athlete, semi-pro or whatever, they actually have to carb load to make sure that they maintain the protein. I mean, that sounds strange. You have to have carbs in order to maintain protein, because you need carbs to build protein. But they will often, the first exercise of the day will be fasted.
Yeah. We noticed, and that's what I was saying to you earlier, it was interesting through having the fitness center for years and through David with the elite athletes, like noticing them, they would be in, and they still are in at 6 a.m. in the morning, exercising first thing generally before they have eaten breakfast, and do a huge big training session, and then they'll go and have breakfast, and then there's the next session down the track as well. So I've got one question here too that I wanted to ask you, that someone said that in regards to, if a person should take mid-morning, like the 24/7, because they just find that they're hungry. So if they're having it first thing in the morning, should they then take mid-morning, 8:30, 9:30, because they're hungry? And then bedtime is 10 o'clock, and they're up at 4 a.m. in the morning, so their time schedule isn't the conventional, because they're up early and they're working early hours. So how do you manage that, like with the time frame for people that are doing night shift or are doing late shifts or early shifts? So is it the same principle with their food regime? They just alter it because of what their sleep cycle is?
Yeah, they need to go with their cycle, not based on the time of day. When they get up, that's when they should do it. Start when you get up. Use that at the start of your day, and then do that exercise, and then have something to eat, and then go to work or whatever. That's when you should start. I would say the 24/7, the red one does have some natural components in it that helps with your appetite. So it doesn't matter when you get up, start your day then. So most people, 6 to 8 o'clock, if you're getting up on the third shift and you wake up at 10 p.m., use that as the start of your day. You have much more difficult time, of course, because of the light cycle, but get up at 10, flood yourself with light, blue, bright light, white, pretend that's the sunrise, and start your day then.
Awesome. Okay, Dr. Ahrens, I want to thank you so much, because I think it's been really enlightening in regards to being able to understand why it's important to consider intermittent fasting, and how we can benefit from being able to manage our weight more efficiently by understanding when to eat and why timing is so important. And regardless of whether we're getting up at 2 a.m. in the morning, and that is when our job starts, like we're starting at say 4 a.m., then we just need to adjust our dietary intake depending on when our day starts, from my understanding from what you've said. Is that correct?
That's correct.
Okay. So I want to thank you so much. And I really want to thank everybody that's been on this call today, that's taken their time out of their schedule to listen to us, or listen to Dr. Ahrens, I should say. And for those that watch this recording later on or share it, thank you so much. Next week, we've lined up some people to do some reviews, like testimonials next week. So make sure that you do plug into that, because it's always good to hear about somebody else's journey in regards to how they've had an experience on what they're using with Dr. Ahrens products and others as well. So thank you so much, Dr. Ahrens, and thank you everybody for joining us today. We look forward to seeing you next week, and have a great weekend.
Bye-bye. Thank you,
Bye.
everyone.